Hej allesammans och varmt välkomna till årets upplaga av EDAY. Tidsenligt så är det ett digitalt arrangemang. Mitt namn är Maria Huge-Brodin, jag jobbar som professor i miljölogistik och jag kommer att vara er moderator för dagen. Och jag tycker att det här är extra roligt eftersom temat för dagen idag är elektrifierade godstransporter. Det är en väldigt viktig del av den forskning jag och mina kollegor bedriver. Så jag ser fram emot med spänning att få höra olika deltagare berätta och diskutera kring det här temat. Vi har med oss 120 stycken anmälda deltagare. Det är väldigt roligt. Vi hoppas att ni får mycket med er härifrån idag. Och vi har ett digert schema framför oss. Vi har 3 stycken fullspäckade timmar under årets tema som är elektrifierade godstransporter. Och med programmet så vill vi ge en inblick i dagens utveckling. Var står vi idag? Men också, vart är vi på väg? Vad finns det för möjligheter? Och hur kan vi alla bidra till att driva utvecklingen framåt? Programmet består av 3 delar. Med ett par mycket korta bensträckare mellan de olika delarna. Först ut så har vi vår keynote speaker för dagen som heter McKinnon. Jag introducerar honom alldeles strax. Den delen kommer att vara på engelska. I timme 2 så har vi 3 stycken spännande föredrag från olika myndighetsrepresentanter som kommer att prata om hur de i sina olika roller kan möjliggöra elektrifiering av transporter och godstransporter i regionen men också på en bredare nivå. Sista delen, då kommer vi ha en kort presentation och så en paneldebatt mellan olika aktörer som rent operativt och verksamhetsmässigt kan hjälpa till att bidra till elektrifiering av godstransporter. Avslutningsvis så rundar vi av EDAY med utdelning av miljöteknikpriset. Än en gång varmt välkomna till dagens EDAY. EDAY ordnas varje år för er som inte har varit med förut. Några av er kommer säkert tillbaka för att det är intressant och spännande. Och det hoppas vi att ni som är nya i år också kommer att kunna göra. Bakom arrangemanget står 5 stycken olika aktörer. Region Östergötland, Länsstyrelsen i Östergötland, Linköpings Universitet, Cleantech Östergötland och LRF. Och nu vill några av arrangemangerna välkomna ert deltagare till dagens EDAY. Och först ut är Martin Tollén, andre vice ordförande Region Östergötland.
Tack så mycket Maria. Tänker om vi börjar med att för ett ögonblick fundera på varför gör vi det här? I förlängningen så handlar det om att vi vill att Östergötland ska vara en bra plats att växa upp i. Det är här som du vill leva och det är här som du vill bedriva din verksamhet. Det gör att de globala målen också är östgötska mål. Idag kommer vi väldigt mycket att utgå från mål nummer 9 om hållbar industri, innovationer och infrastruktur. Jag heter som Maria sa Martin Tollén. Jag är förste vice ordförande i Trafik och Samhällsplaneringsnämnden i Region Östergötland där jag representerar Socialdemokraterna och östgötarna naturligtvis. Tillbaka till varför vi gör det här. Till hållbar industri, innovationer och infrastruktur. Allt för ofta uppstår det diskussioner om vilken sorts hållbarhet som är den bästa. Till exempel elektrifiering eller flytande biogas. Vi har inte tid med det. Omställningen till hållbara transporter den brådskar och flera olika lösningar kommer att behövas samtidigt. Det är därför Region Östergötland är med och arrangerar EDAY med temat elektrifierande godstransporter samtidigt som vi är engagerade i Biogas Research Center på Linköpings Universitet. Det är därför vi stimulerar elektrifiering och bedriver ett intensivt påverkansarbete för biogasens förutsättningar. Vi har också en institutionell styrka i Östergötland som vi brukar framhäva i våra kontakter med andra regioner. Och det är att vi har Sveriges bästa länsstyrelse. Jag har varit landstings- och regionpolitiker i mer än ett kvartssekel. Och ibland har vi sprungit på varandras tår och ibland har vi konkurrerat. Men nu, och särskilt i den här frågan, så jobbar vi som ett. Vi har en gemensam energi- och klimatstrategi för hela Östergötland som har antagits av både regionfullmäktige och av Länsstyrelsen. Och för att genomföra strategin och förverkliga våra ambitioner så fortsätter vi arbeta tillsammans. Till exempel genom att använda vår samlade kompetens och tjänstepersoner på bästa sätt. Och genom att vi tillsammans står bakom ett arrangemang som idag, EDAY. Sen har vi också det som i mitt tycke är Sveriges bästa universitet i vår region. Jag nämnde Biogas Research Center, men det är naturligtvis bara en liten del av allt det som pågår på LIO. Maria Huge-Brodins forskning är ett annat strålande exempel på det, som gör Östergötland till en bra plats att växa upp i. En region där du vill leva och bedriva verksamhet även i framtiden. Och det är ju det som är anledningen till att vi gör det här idag. Från min och region Östergötlands sida, välkommen till EDAY 2021.
Tack så mycket Martin. Då vill jag lämna ordet till våran landshövding, Fredrik Graf.
Hej, vi på Länsstyrelsen Östergötland vill naturligtvis också hälsa välkommen till EDAY. Jag är glad över att det är så många deltagare med varierad bakgrund som har anmält sig till det här webbinariet. Vi tror nämligen starkt på regional samverkan. Det är viktiga framgångsfaktorer för att vi ska nå våra mål om att skapa effektiva och hållbara lösningar för framtiden. Och dagens tema handlar ju om att vi ska kunna ställa om och elektrifiera delar av transportsektorn. Jag tänkte nämna några exempel på hur vi på Länsstyrelsen arbetar med de här frågorna. En sak som jag är extra glad över, det är vår energi- och klimatstrategi som vi tog fram tillsammans med Region Östergötland och en rad olika aktörer. Den ger oss en övergripande vägledning för hur vi kan arbeta med de här frågorna. Men där ingår också 6 olika handlingsplaner och 2 av dem där arbete nu pågår adresserar särskilt transportsektorn. Det handlar om hållbara och effektiva transporter men också om förnybar och robust energiproduktion. Jag tror den här typen av arbete som stärker samverkan och som också tar fram och belyser synergieffekter, det är väldigt viktigt. Men vi ska heller inte blunda för att det finns målkonflikter. Och har vi aktörer med olika bakgrunder, då kan vi adressera de målkonflikterna i tid och också göra någonting åt dem. Från Länsstyrelsens sida arbetar vi också med en rad olika projekt inom det här området. Vi medverkar till exempel när det gäller den regionala planen för infrastruktur för elfordon och förnybara drivmedel. Ett annat projekt är Fossilfritt 2030 och vi deltar också i en förstudie när det gäller vätgastankställen. Så det finns med andra ord väldigt mycket som pågår både hos oss på Länsstyrelsen och en rad andra aktörer här i länet. Och det gör ju när vi jobbar med de här frågorna att vi i allt snabbare takt kan ställa om till en elektrifierad struktur för godstransporter och för transporter i allmänhet. Jag hoppas att ni ska tycka att den här dagen ger er både ny kunskap, ny energi och kanske också ny inspiration att gå vidare med de här viktiga frågorna så att vi kan snabba på omställningen till ett fossilfritt Sverige. Och jag ser fram emot de långsiktiga effekterna som det här seminariet kommer att föra med sig.
Tack så mycket Fredrik. Själv jobbar jag på Linköpings Universitet som också är en av arrangörerna bakom EDAY. Och jag har då nöjet att meddela för er som inte har hört det förut att Linköpings Universitet nu gör en kraftsamling inom just transportforskning, styrkeområde transport. Universitetet har ju lite olika roller i utvecklingen. En av de allra viktigaste vi har är att vi utbildar studenter som ska komma ut i verkligheten och verka och bli morgondagens ledare och deltagare i utvecklingen. Det gör vi inom transport, vi gör det inom miljö, inom väldigt många olika områden förstås som är relevanta för dagen idag. Vårt andra stora ben, det är forskningen. Och vi har en stor bredd på forskningen inom transporter. Det är därför vi har det här styrkområdet. Vi pratar digitalisering, vi pratar autonoma transporter. Själv jobbar jag med logistikfrågor. Vi har också olika typer av beteenden som vi beforskar på olika sätt och vis. Så vi har en väldigt stor bredd och vi får därmed en stor förståelse för problematiken tycker vi. Och det är viktigt för oss i vår roll som internationella forskare. Vi måste nå ut, vi måste finnas med i den internationella debatten för att driva forskningen. Hjälpa till och påverka forskningen i hela världen och ta till oss av det som sker där ute. Men precis lika viktigt för oss som forskare är den regionala förankringen i det vi håller på med. Vi måste ju finnas på plats där det händer. Vi måste kunna studera där verkstaden verkligen är. Och där våra företag som vi ofta studerar och arbetar tillsammans med utför sina verksamheter. Och speciellt för mig då inom miljörelaterad logistik, transporter som är väldigt viktigt. Så LiU vill också hälsa alla välkomna därmed till den här dagen som representerar en viktig del av LiUs verksamhet. Nu kommer vi gå över, jag kommer strax introducera Alan McKinnon. Innan dess vill jag bara passa på att uppmana er alla som sitter och tittar att vara aktiva i chatten. Det finns en chattfunktion som ni kan skriva i. Och till min hjälp för att facilitera chattandet så har jag Per Lindahl från Logistikia som är det regionala nätverket för logistik i Östergötland. Så skriv till chatten så kommer Per att hjälpa mig att spela in frågor när vi har möjlighet att ställa frågor. Så. Och då kommer Per också visa sig i bild förhoppningsvis när vi får frågor. Så passa på att chatta, lyssna och delta i diskussionen. And now I would like to introduce my colleague and dear friend Alan McKinnon. Alan, are you with us?
Yes, I am.
Hello, good to see you.
Mm-hmm.
And to introduce Alan, for those of you who haven't met him, Alan McKinnon, he's the pioneer in research into green logistics. And since the 1990s, he has advocated the need for considering environmental aspects, not as a trend, but as a change of mindset. Alan has led numerous projects and research projects and programs in the UK as well as the EU. And he's also an advisor to companies and to policymakers. He was previously the Professor of Logistics at Hertford University in Edinburgh, Scotland, and is now Professor of Logistics and Honorary Senator at KLU, the Kuhne Logistics University in Hamburg. Warm welcome to you, Alan. And if you were here, I would say the floor is yours, but I can't say that right now, so I'd say the space is yours. Warm welcome.
Great. Well, thank you very much, Maria, for that introduction. It's a real pleasure to be invited to speak at this event. I'll just share my screen at this point. And I hope you can see it says the host has disabled participant screen sharing. Yeah, that's great. Here we go. So I hope you can all see that copy of my presentation. Perhaps I should say a few words about my university. We think we're the only university in the world which specialises in logistics. It was founded in 2010. It's a private university but state accredited. We're small. We've got about 25 professors and about 400 students. And we're based in the harbour quarter of Hamburg. Although I actually I'm Scottish, as you may gather from my accent, and I'm talking to you today from my home in Edinburgh, and I have no idea when I'll be able physically to return to my university in Hamburg. So I'm going to talk about decarbonising logistics. I've packed a lot into this presentation. There'll be a copy of it available for you if you want subsequently. I'm trying to give you a broad overview of the subject, but I always like to start by saying a few words about the climate science, just to impress upon people the scale and the urgency of the challenge. This is a graph which I think very neatly sums up what now confronts us. It shows the rate at which CO2 emissions have been rising, and the rate at which they must now reduce if we are to stay within a 1.5 degree temperature increase. The feeling is if we go beyond that, then we will suffer severe environmental consequences in terms of extreme weather events, rising sea level, and so forth. Now, if we had started reducing our emissions back in the year 2000, then we could have more gradually reduced our emissions to stay within the 1.5 degree carbon budget. The trouble is we didn't. The emissions are still rising. They have not yet peaked. And now for us to stay within that target, we have to have a precipitous reduction in emissions. Indeed, to have a 2/3 chance of staying within a 1.5 degree temperature increase, we only have about 8 years of emitting at our current level if we're going to stay within that budget. And if we overshoot, then much of our time, effort, resources will have to go into absorbing greenhouse gases already in the atmosphere, what they call negative emissions. So that gives us a sense of just what we have to do and how quickly we have to do it. Now, moving on to talk about logistics. What is the carbon footprint of logistics? It's estimated that about 10 to 11% of energy-related CO2 emissions worldwide come from logistical activity. And most of that comes from transport, as you can see. Warehousing, terminals probably are just over 1%. Nobody has yet, to my knowledge, carbon footprinted the administrative and IT aspects of logistics. But if you factor all that together, we get this average figure. The feeling is that logistics is going to be a very hard sector to decarbonize, mainly for two reasons. One, because of its almost total dependence on fossil fuel currently, but also because of the very high forecast growth rate in the level of freight movement. The International Transport Forum, for example, which is a very elaborate global model of freight and trade, estimates that there'll be about a 3.3 times growth in freight movement. That's measured in ton kilometers between 2015 and 2020. And that's going to make it very hard to decarbonize this sector. Now, of course, a year ago, we had COVID. The ITF did some modeling at that time, and they reckoned at the time of maximum confinement between about March through to May last year, that freight CO2 emissions worldwide dropped by about 28%. And that was an interesting figure because the year before they had come up with this, what they call current ambition scenario, which would see freight CO2 emissions drop by 30% between 2015 and 2030. So what COVID effectively did was deliver within a 2 or 3 month period a level of reduction in emissions that they were anticipating over a 15-year period. But of course, that was only temporary. And of course, as the economies have rebounded, so too has the level of freight CO2. But what that did demonstrate was the magnitude of the challenge that we have in driving down CO2 emissions to stay within our carbon budgets. So how do we do that? Well, basically, there are 5 sets of initiatives you can deploy to decarbonize logistics. I'm going to focus very much, because time is limited, on freight transport. I'm not going to say very much about the warehousing and the terminals in this presentation. Now, in the transport decarbonisation world, many people talk about the ASI framework: avoid, shift, improve. I always think it's helpful when talking about freight to divide the improve category into 3 separate sets of initiatives. So we start off by looking at what we can do to reduce the total amount of freight movement. Then we look at how we can shift freight to lower carbon transport modes, for example, from road to rail. Then we look at how we can optimize utilization of vehicle capacity, how we can then increase the energy efficiency of freight transport, and then finally to cut the carbon content of the energy that we use in the freight transport system. And I'm going to be looking at each of these sets of options in turn. But just before doing that, just to give you, again, a sense of the challenge that now faces us, if we look at the situation in the EU, so the EU Green Deal wants to see emissions from transport, that's both passenger and freight, reducing by about 90% by 2050. So what one can then do is construct scenarios to see how that might be achieved. So here is one scenario. So if we then, at a European level, shifted about 30% of road ton kilometres onto the rail network, and in the meantime, if the rail network reduced its carbon intensity by 80%, then if we improved the routing, the efficiency of the routing of trucking by about 1/4, improved the loading of the vehicles by 30%, 30% reduction in empty running, 50% improvement in truck energy efficiency, and a 60% drop in the carbon content of truck energy. Factoring all of those things together would give us our 90% reduction in carbon intensity. But those people who work in the logistics world will know just how hard it would be to achieve all of those things, even over a 30-year time period. Now, that's just one scenario. Another scenario would be one in which we rely more heavily on reducing the carbon intensity of the energy used. And if we did that, then that would take some of the pressure off those other decarbonisation levers. But the other point to note is that these scenarios are static. We've got to build in the time dimension here, because we really want to see our freight emissions peak as soon as possible and then drop. Because the longer we leave it for the emissions to peak, the more steeply they will have to drop subsequently. And I illustrate this very simply in this diagram. Two scenarios there, one where they peak in 2025 and then drop to 2050, and then, but if we delay until 2035, then over that time period, we put about 28% more CO2 from the freight sector into the atmosphere. And remember, it's the accumulation of greenhouse gases in the atmosphere which drives climate change. So again, it demonstrates the need for us to act very quickly to try to decarbonize this sector. Now, how do we do that? Well, let's start looking at the 5 sets of initiative. How can we just reduce the demand for freight movement, or slow the rate at which freight movement is increasing? Now, this can take us beyond the world of freight transport. It can take us into looking at sustainable consumption and the dematerialization of stuff, of product. And there are a number of developments here will help. I mean, if we do move into a share economy where people are less keen on ownership and more willing to share and see the multiple use of products, that will reduce products. Applying the principles of the circular economy will greatly help if we increase recycling or remanufacturing. We can redesign our products with less material. That's obviously happened in some sectors like electronics through miniaturization and lightweighting. We also can digitize more products. We already do that with entertainment media and education and news. We could increase that, essentially converting consignments into electrons. We may also be able to rely on 3D printing. Some people think that's going to be a decarbonization game changer for supply chains. It will help certainly to streamline supply chains, could relocalize production. It will also reduce the amount of materials because there's less wastage in the 3D printing process. But there's a lot of debate on this currently, a lot of uncertainty and disagreement as to what the net effect of 3D printing will be on freight traffic longer term. Another thing we could do within logistics is reconfigure our supply chains, redesign our logistics systems. There's an example of a very simple supply chain. But one thing we try to do is to reduce the number of nodes and links in that chain by encouraging vertical integration of manufacturing, for example. But that would be challenging. It would involve restructuring our economy, and the prospects of that happening, I think, are maybe quite limited. Another thing we can do is shorten the links in the supply chain, reduce what we call the average length of haul, because it's increases in the distance that we move products that has been the main driver of freight traffic growth in the past, where companies expand their market areas or they're sourcing their products over longer distances, or the geographical concentration of production and inventory. These essentially geographical processes have been the main driver of freight movement in the past. So one thing we can consider, therefore, is to put those processes in reverse. We could relocalize economic activity, but we have to be careful because, as I say here, reducing the distance a product travels does not necessarily minimize its carbon emissions on a life cycle basis. Typically, freight-related emissions represent a small percentage of the total life cycle emissions. Most of those emissions come from production-related activities, and therefore it makes sense for us to source products where they are made at with minimum carbon, even if that means we have to transport them long distances. The other thing, as I said, we could do is decentralize production and inventory, reverse that process of geographical concentration. But that, again, would come at a high cost. We would lose economies of scale and agglomeration. In terms of managing inventory, it would increase the amount of inventory in the economy. We would then have to construct a new generation of localized warehousing, and there'd be a carbon penalty associated with that. So that's an initiative, again, which would, I think, have a very high carbon mitigation cost, and it would take time. I mean, that would be decades, perhaps. Moving to the second set of initiatives, which is shifting freight to lower carbon transport modes. Now, this is the option that attracts a lot of political support. A lot of governments are committed to do this. The Green Deal, the EU policy to make Europe the first continent to be carbon neutral in its smart and sustainable mobility strategy, it attaches a lot of importance to getting freight onto lower carbon transport modes. And you can see why. You know, there's a huge variation in the average carbon intensity of freight transport modes. The main choice in many countries, of course, is between road and rail, or perhaps also inland waterways. Now, it's interesting because in my university, we did a survey last year of 92 senior logistics executives across Europe to ask for their views on decarbonizing logistics. And one question we asked them was what they thought the most cost-effective way of decarbonizing logistics would be. And as you can see, top of the list there came shifting freight to cleaner transport modes. So there's a lot of corporate interest these days in shifting mode. But there are problems. In most countries in the world, the railways have been losing market share, and there are very few countries that have managed to reverse that process. Sweden actually comes out of this quite well. I mean, in European terms, Sweden sends a significant proportion of its freight by rail, much more than in other countries. The other problem the railways and to some extent the inland waterways will have is that one of their core traffics in the past has been fossil fuel, moving coal, oil, gas. And of course, as we phase out these fuels, that's going to deprive these cleaner transport modes of that traffic. And it's going to be difficult for them to replace all those ton kilometers. The other thing is, too, in many countries, what you find is the carbon intensity gap between road and rail is narrowing. But the railways have one major advantage, and that is that worldwide, about 50% of rail freight is hauled by electrically powered locomotives. The rail network has a direct connection to the electricity grid and therefore can take advantage of the decarbonisation of electricity. There are other things happening too. I mean, governments are investing in intermodal systems. In Europe, there are 9 corridors in which the EU promotes a switch of freight to intermodal services. There's also a new concept called synchromodality, which more and more companies are adopting, which, as the name suggests, is where companies try to synchronize the movement of freight by different transport modes to reduce delays in the shifting of the transshipment of freight from one mode to another. You can also apply this concept to the way in which companies manage their logistics, where you incorporate the modal choice decision into the way companies do their production planning and their inventory management. So I was involved in a study with Procter & Gamble, which examined the use of this concept, and it demonstrated this could save money and cut a lot of carbon emissions as well. Moving on to the third set of initiatives, which is just making better use of the available capacity in the vehicles. Environmentalists regularly criticize trucking companies, for example, for empty running of their vehicles or for underloading the vehicles. But when you examine the subject in detail, as I've done over the years, you discover it is actually quite complicated. There's obviously empty running of vehicles, and that's a very clear example of underutilization. But on many of the loaded trips, again, the vehicles are underloaded. That can be both in weight terms and also in terms of the proportion of the space in the vehicle which is actually occupied. But that space you can measure either in a two-dimensional way in terms of the coverage of the floor area in the truck or the container, or also a three-dimensional view in terms of cube utilization. The big problem we have as researchers working in this field is getting access to the necessary data to see just how poorly capacity is utilized and what the potential is for cutting carbon by improving that potential. But we do have, in some parts of the world, quite good data. So in Europe, for example, Eurostat compiles statistics on the empty running of trucks. And Sweden actually emerges from this comparison very well, as you can see. So on average, about 22% of truck kilometers are run empty. In Sweden, that figure I think is only about 17%. You're not quite as good as Denmark, but you are at the right end of that spectrum. But if you look at the loading of laden vehicles, you have to be very careful and take account of the density of the load. Because very often vehicles don't reach their weight carrying capacity simply because they are low density products that fill out the space before they reach the weight limit. They use the jargon, they cube out before they weigh out. And so because we lack good data on cube utilization of vehicles, it's very hard for us to estimate what the potential savings are. The other thing is how do we define underutilization? Do we simply do that in terms of the pallets or the cases on board the vehicle? Or do we drill down to look at the use of space within the packaging, for example? Because there's a lot of talk these days about the right sizing of packaging. So the packaging actually matches the dimensions of the product. Some companies like Unilever have been very good in using concentrates, for example, and with their SIF product. They claim that by using concentrates and reusing the packaging, you can achieve almost 90% reduction in road freight. We can also vacuum pack clothing, for example, to reduce their cube. So there are a whole range of things that we can do here to make better use of vehicle capacity. But the beauty of this is it offers large carbon savings, right? There's a monetary saving as well. So the carbon mitigation costs are low, in many cases even negative. And this is a measure that can be introduced reasonably quickly. But, there are many perfectly good reasons for vehicles not being fully laden all the time on every trip that they make. Now, it would take me half an hour just to discuss this one table, but what it does illustrate is the whole range of factors that constrain the loading of vehicles. And many companies find it difficult to relax those constraints, but there are things happening which are encouraging this. One is logistical collaboration. There's a general feeling that for us to achieve deep reductions in emissions from freight transport, that companies will have increasingly to share their vehicle capacity. Now, supply chain collaboration has been debated for years. Still, it's the exception rather than the rule. But I think more and more companies through time will start to share their vehicles, and that will help to improve load factors. The second thing is digitalization. The survey I mentioned a moment ago of these 90 logistics executives, they said that they reckoned that digitalization would have a transformational effect on logistics in Europe over the next 5 years. And much of that will translate into lower carbon emissions through things like online procurement and the routing and scheduling of vehicles. Another thing is what we call high capacity transport, longer and heavier vehicles. Now, in Sweden, you are experts at this. You've allowed these vehicles to operate now since the 1960s. And because of that, the carbon intensity of road freight in Sweden is below that in many other countries, because you permit the consolidation of freight in these longer and heavier vehicles, but other countries that are an earlier stage in that process. And then finally, there are radical things we could consider, like possibly relaxing the just-in-time principle, which is often accused of causing the underloading of vehicles. And it's quite interesting that during the COVID period, when many companies began to think of improving the resilience of their supply chains, that there was discussion of perhaps companies relaxing just in time, and that would then have an effect on the loading of vehicles. The fourth category of measure is improving energy efficiency. Now, there are some things we can do longer term to reduce energy consumption per ton kilometre or vehicle kilometre. We can obviously redesign the vehicles in vessels and aircraft and so forth. Not just for individual units, we can use platooning, for example, where we have convoys of vehicles running closely together to help to minimize fuel consumption across the whole group. We can automate vehicles because the feeling is computers will drive trucks more fuel efficiently than will human beings. Governments are contributing by introducing fuel economy standards, requiring manufacturers to achieve certain fuel economy standards in their vehicles or in vessels. In the case of the International Maritime Organization, the International Aviation Authority also hopes to see a 2% per annum improvement in energy efficiency in aviation. But as I said, we cannot wait until a lot of these longer term developments occur. We have to look for short-term measures, and one thing we can there do is retrofit fuel-saving devices to freight vehicles. One of the most cost-effective ways of decarbonising logistics is to train truck drivers to drive their vehicles more fuel efficiently, and then to monitor their driving behaviour and if necessary, give them guidance thereafter. We can enhance vehicle maintenance of the vehicles. We can change business practice. One thing we can do is just slow down the vehicles. I published a paper in 2016 looking at deceleration as a way of decarbonising logistics. Many people thought I was a heretic, and this was because the feeling is that progress means speeding up. But perhaps in a low carbon world, we just have to start slowing things down. This has already happened in the shipping industry, and there are also some trucking companies now which are setting the governors on the engine at a slower speed, and that cuts carbon emissions. And then moving on to my fifth category of initiative, which is reducing the carbon content of the energy, switching from fossil fuel to renewable energy. Now, for the different transport modes, there are lots of energy options, as you can see in that table. The problem is, at the moment, there's a lot of uncertainty as to which will be the dominant alternative energy for these transport modes. A lot of disagreement. There's a lot of lobbying currently. And unfortunately, we just don't have the time to endlessly debate this. We really have to get a clearer idea as to what the right energy options will be. The other problem we have is the lifespan of the assets. You can see the typical lives here of trucks and locomotives and ships. These are long-term assets. So replacing the current generation of fossil fuel locomotive, ships, airplanes, trucks is going to take a lot of time. And what we then have to do is to coordinate the development of a new transport energy infrastructure for these renewable fuels with the manufacture of a new generation of vehicles. And that's going to be a real challenge, as we're already beginning to see in the road freight sector. Personally, I think the main way in which we're going to decarbonize by energy use is by electrifying as much freight transport as possible, and then relying on the decarbonization of electricity. But currently, as you can see from that graph, map from the International Energy Agency, there are huge variations worldwide in the average carbon intensity of electricity. In Europe, electricity, the carbon content of electricity is dropping quite steeply, and that's projected to continue. Again, I'm saying lots of very complimentary things here about Sweden because you're so lucky in having very low carbon electricity. The last figure I saw was something like 7 grams of CO2 per kilowatt hour, which is, I think, about the lowest in Europe. Maybe you compete with Switzerland possibly for that. That is a huge advantage you have in trying to decarbonize your logistics. But looking at this more generally, one of the issues is, will there be an adequate supply of low carbon electricity in the future to electrify as much of our freight transport as we possibly can? Now, if we look at particular modes, I think there's general agreement that the way in which we decarbonize local delivery operations is by using battery-powered vehicles. The vehicles are currently increasing their delivery range. We're seeing an expanding recharging network. The price differential between battery-powered vans and diesel or petrol-powered ones is reducing. Indeed, it's argued, I think, in terms of the total cost of ownership, it's as cheap now buying a small van, an electric one, as it would be a diesel or petrol-powered one. And this is largely because of the collapse, really, in the price of lithium-ion batteries. As you can see in that graph, and they're anticipating that by 2025, that cost will be below $100 per kilowatt hour, which will then greatly improve the economics of electrification. More of a challenge for long-haul vehicles. There are a number of decarbonisation options. Again, you can have a battery-powered truck, one using a hydrogen fuel cell, or you can electrify the highway and draw power from overhead, or you can use biofuel or synthetic fuels as well. The ones I'm going to focus on here are the top three, which I think are the main candidates. To complicate things, oh, right, okay, thank you. I'm not too far from the end. We can also use hybrids. Now, there have been various studies comparing these different ways of decarbonising trucking. Hard to compare them because they use different methodologies and different analysis, and different truck manufacturers are now adopting different strategies. There was a feeling in the past that we couldn't do this using batteries because the batteries would be too heavy. It would take too long to recharge them. They'd be too expensive. But in recent years, there have been major advances in battery technology as it relates to trucking, so that many people now think for smaller countries, probably batteries will be the main way which will electrify trucking. There is highway electrification. Again, Sweden has shown great interest in this. You've got trials running, as they have in Germany and also in California. And I think almost certainly that will make a contribution. For longer hauls. The data suggests that in Germany, a lot of the CO2 from trucks comes from the Autobahn network, and it's been suggested by the main German Industry Association recently that between 4,000 and 8,000 kilometers of Autobahn should be electrified at some stage as well. But it is expensive. There's a high capital cost, and again, there's a problem of coordinating the construction of the e-highway infrastructure with the manufacture of the trolley trucks that will then use that infrastructure. So again, there's a challenge. And then there's hydrogen. It gets a lot of attention these days. When we did our survey I mentioned earlier, we asked what the managers thought should be a key element in the EU Green Deal here, and they said support a switch to hydrogen propulsion. We did another survey of 800 small trucking companies in Europe, and we asked them what they thought the main energy source should be in the future, and again they said hydrogen. And I just wondered, why is there so much support for hydrogen? Okay, it offers you a longer range for the vehicle, it's more rapid refueling, there's less of a weight penalty. I suspect a lot of it is probably hype as well. And I may be offending people in the audience who are big advocates of hydrogen. But at the moment, hydrogen is essentially a fossil fuel, right? 95 to 97% of it's produced from natural gas. It's only when we get to green hydrogen, made from the electrolysis of water using low carbon electricity, only then will it be a truly green fuel. But unfortunately, that electrolysis process uses a lot of energy. You lose about 70% of the energy in the process. And for a long time in the future, low carbon electricity will be a valuable commodity, and it's debatable if we should use it in that way. And work done in the UK also suggests, exactly, if you're generating that low carbon electricity using wind turbines, if you're using the hydrogen pathway to decarbonisation, you would need an awful lot more wind turbines and more land and so forth. So I personally am a bit of a hydrogen skeptic. And also maybe hydrogen should be used in those transport modes which are harder to electrify using batteries and cable, like aviation, for example, or shipping, where you could put the hydrogen into ammonia, or even barges. So maybe that's where we should be focusing the use of hydrogen. But I think all of those different energy technologies will probably compete. They all have what we call sweet spots in terms of their operational capabilities. So they will all coexist in some, but it's debatable as to what their relative contributions will make to the decarbonisation of freight. I'm rattling through this quickly so I leave time for questions. The other thing is, if we look at the trucking sector, it's going to take a while to transform to end what they call the Ice Age, the internal combustion engine era. It's estimated by 2030 there'll still be 70% of the trucks on German roads will still be powered by diesel. At a European level, it could be as much as 90%. As you can see, the rate at which we replace truck fleets is relatively slow. At a European level, it's something like about 13 or 14 years it takes to replace. So even when we start mass producing electric and hydrogen trucks, it's going to take a while to change all of that. One positive thing, I said I wouldn't say much about warehousing and distribution centres and ports and so forth, but those premises, those buildings will be much easier to decarbonise than transport because they're plugged directly into the grid, and so will take advantage of low carbon electricity. And they can also micro-generate their own renewable energy using solar panels and wind turbines. I'll draw attention to what's regarded currently as the most environmentally friendly building in the world. It's a distribution centre in Tilburg in the Netherlands, which has a roof covered in solar panels, which doesn't just generate enough electricity to run the warehouse, but it also powers the equivalent of 750 houses in the surrounding area. So it's what we call a carbon negative climate. Yeah, thank you. And just again, it take me 10 minutes to talk about this. What's happening at the front end of our supply chains with the growth of online retailing, which has obviously been reinforced by COVID. We've done a lot of work looking at the relative carbon impact of online and conventional retailing. And I'm actually quite positive about this. A lot of online retailing actually yields a carbon benefit. But with the growth of last mile delivery, again, we're seeing a huge increase in CO2 emissions. It's projected by a study by McKinsey and the World Economic Forum to be a 1/3 growth in emissions from last mile delivery. However, they've come up with a scenario involving the use of electric vehicles, nighttime delivery, parcel lockers, and also consolidation of freight across the different carriers. And if all of those things were combined, they reckon that could cut emissions from last mile delivery by about 30% by 2030. And then just my final slide. I published a book on decarbonising logistics, which is partly based on a framework I came up with called the 10C framework for decarbonising logistics. 10C because it's 10 English words beginning with the letter C. First is corporate motivation. So this can be applied to companies, it could be applied also to public organisations. So you've got to start with the motivation, you then calculate your emissions, you then commit to targets for reducing those emissions, you consider all the possible options for decarbonisation. At that point, you should look at potential for collaborating with others to share assets. You then have to look at the cost implications of all of this. In the light of all that information, you then choose those decarbonizations most appropriate to your business or your organization. At that point, you might consider carbon offsetting to help you reach your targets. You then implement your strategy, you cut your emissions, and you learn from that process. And in the light of that, you put in some feedback loops, you recalibrate the strategy, you may have to increase your targeting or reevaluate your costs. Now, the question is, although that was developed originally for businesses, to what extent can that be applied to local authorities? Because I think in the audience there are municipal authorities represented. Well, it can, because in the case of corporate motivation, for example, clearly municipal authorities are under sort of top-down, bottom-up pressures. You've got an electorate to satisfy, but you also have government to, yeah, and that's exactly what I'm doing. So. And in the case of calculating emissions, again, you've got boundary issues to look at for your areas. Committing to targets, can municipal authorities do that in isolation, or do they align that with government goals? Cost evaluation applies as much to public initiatives as it does to corporate ones. Local authorities can collaborate just as much as businesses can. There's a debate as to whether it's legitimate for local authorities to engage in carbon offsetting. But anyway, so I think that's my last slide. So I hope you found that of interest. I've got some conclusions there. I don't really have time to go through them, but I think you got the general message. Those are my contact details. As I said, you can have a copy of this presentation. There's my book on the subject, and I'll be happy to answer any questions that you might now have. Thank you very much.
And thank you very much, Alan. You would have gotten a big applause if you were here, of course. So let's just imagine how wonderful it would have been.
Yes, okay. Yeah.
And as always, you provide the complex picture of this problem all over. It's not very easy to pick one or two things to do from this. But you also, I think you have given a lot of advice, in particular to companies, of how they could do, freight companies and also shippers, those who order transport, how they could do to lower their carbon impact and so. But I have an overall question. You mentioned Sweden in a couple of examples where we had a good spot. We had low degree of empty running, for instance, and we have a very good position in low carbon electricity compared to other countries. But do you think there is another area or some other areas where we could improve? We often think that we are very good at things, but we could also benefit from hearing where we could improve, or what would be the most important thing to do for Swedish companies, authorities, so on. If you have any advice on that.
Yeah, well, yes. I suspect I just don't have a detailed enough knowledge of the logistics of Sweden to do that. I've been many times to Sweden, and I was a guest professor in Linköping as well. I know that you have a fossil-free freight initiative, a sort of public-private initiative, which is currently investigating all the opportunities. In a sense, in Sweden, you're starting from a higher baseline. You know, because as I said, you send more freight by rail than in other countries. The low carbon electricity you have is obviously very beneficial. The fact you have longer and heavier trucks and consolidate freight to a greater extent are all very positive. So that gets you to a higher level than many other countries in this decarbonisation process. Other things. A lot of what's happening elsewhere, again, can be done equally well in Sweden. Circularity is an issue. So I think across the whole of the EU, the economies are only about 12% circular. So there's a huge potential there to recycle more, remanufacture more, which will reduce the demand for freight transport, and again will translate into a lower carbon footprint. But I honestly can't say that I'm aware of something you do badly in the logistics sector. You know, some glaring example of inefficiency, for example. You know, I'm not just saying that because I'm being polite. I really just don't know. So, but I think you shouldn't be complacent. The fact you're good at doing this at the moment means that you should sit back. I mean, I think you still have to pull all of these decarbonisation levers reasonably aggressively to get down to a net zero logistics system in Sweden over the next few decades.
Yeah, it's still a small country with a minor contribution to this, but we could keep up the good pace then. There are a few questions from the chat. Per?
Yes, thank you, Alan, for a very interesting presentation. I especially like the complexity that you paint here. And that is to meet the complexity of the electrification, which is really interesting. I have one really technical question for you. I have many questions, but we only have time for one. In Sweden, there are several electrical road systems on test, not only catenary. What's your view on that, finding a standard?
Yeah, you're right. I think there's three ways of doing it. There's the catenary system with the overhead cables, which is the one where we've had decades of experience in the rail network, obviously. And then there's an induction system where it's on the road, or there's a physical connection between the vehicle and a rail on the road. I mean, of those three technologies, the one which is most advanced, most mature is the catenary one. And I think that's the one which is going to be the most successful longer term. The one reason that's being offered for using a road-based system is that it can then be used for other categories of traffic and not simply for trucks. But other categories of traffic, particularly cars, you don't need to get the power from the network. You can get that from batteries. And so my vote really would go for the catenary option. And the trials that have been held in Sweden and also in Germany and in California have been very successful. So the issue for me really is what proportion of the decarbonisation of trucking will come from highway electrification as opposed to batteries or possibly a bit of hydrogen. Because with the improvement of battery range, recharging times accelerating, in a sense it reduces the need for making that big capital investment in highway electrification. And I can understand why politicians might be hesitant in approving that investment just in case further advances in battery technology makes that unnecessary, and we'll be left with this stranded asset, you know, a lot of highways with catenary systems that are underused, and you know, there's some thoughts on the subject. Yeah.
Thank you. Catenary är för de som inte kan det. Jag slog upp det en gång. Det betyder luftledning. Thank you, Alan.
And thank you very much, Alan, for your fantastic speech and providing us with some good food for thoughts for the next remains of the day. Thank you very much. I hope to see you soon again.
Thank you, and enjoy the rest of your day. Thank you very much.
Thank
Bye-bye.
you. Då går vi över till svenska och nu tar vi 5 minuters paus. Vi kommer tillbaka klockan 10.00, nästan 5 minuters paus.